This video will be a kind of review of conic sections because I'm going to give you a variety of information pertaining to a hyperbola or a circle or a parabola or an ellipse. And you will use that information to form the standard form equation. In each case, our best bet will be to sketch a graph of the information that we have. So, number 9 is about a hyperbola with vertices at -5, 5. Alright, so -5, 5, there's a vertex. And -5, 1. Alright, so vertex, vertex. Now we have co-vertices at -9, 3. Let's see, what color will I do? My co-vertices, -9, and -1, 3. Okay, I can use these vertices and co-vertices to find the center. The center should be right in the middle between all four of these. So we should be able to easily tell. Let's see, let me write this off to the side. The x-coordinate of the center is -5, just like the vertices. And the y-coordinate of the center is 3, just like the co-vertices. So the center is -5, 3. Also, because this is a vertical parabola, so hyperbola, these are the vertices, which means that ultimately the branches are going to be facing upward and downward. Okay, this is a vertical hyperbola. And whenever I have a vertical hyperbola, the y term goes first. So I know that I'm dealing with an equation that is of the form y minus k squared over a squared minus x minus h squared over b squared is equal to 1. The y term has to be first because it is vertical. Now, since the center is -5, 3, I'm going to do the opposite of both of these. So because of the 3, and that's a y coordinate, I'm going to have -3 right here. So let me just clear this out. So because of that y coordinate of 3, I'm going to have -3. Because of the x coordinate of -5, I'm going to have +5 right here. So now all I need is the a squared and the b squared. Well, a is always going to be the distance from the center to a vertex. Alright, that is a right there. Well, this is from 3 to 5. So a is 2, which means that a squared is 4. So I'm going to have 4 right here. And then b squared is going to be the distance, well, b is the distance from the center to a co-vertex. Okay, so from the center to a co-vertex, that's b. Well, let's see. This is from -5 to -1. That's a distance of 4. So b is 4. Therefore, b squared is 16. And that's it. This is the standard form equation of the hyperbola. For number 10, we're told that we have a circle that has a diameter and we're given the endpoints. So here's my picture. Alright, the diameter goes right through the center of a circle and I've got the endpoints. To write the equation, we need two things. We need the center and we need the radius. So we could find the center by finding the midpoint of this segment. So the way the midpoint works, okay, the midpoint, which in this case will be the center, it's just the average. The average of the x-coordinates and the average of the y-coordinates will give you the midpoint or the center. And when you find the average, you're adding them up and you're dividing by 2. So if I take -8 plus 2 and I divide by 2, I'm finding the average of the x-coordinates. Now I'll do the same thing with the y-coordinates. 29 plus 5 divided by 2. If I simplify this down, I will have the center. So this is going to be -6 over 2, and this is going to be 34 over 2. So this is going to be -3, 17. So this is the midpoint, -3, 17. So that's most of what I need in order to write the equation of the circle. But I also need the radius. Now the radius of the circle is going to be the distance from the center to one of these points on the end. I could pick any two of these and do the distance formula. Okay, I'm going to pick these two just because the numbers look smaller. So if I can find the distance between these 2 points, that'll be the radius. So the radius, the distance formula goes like this. It's the square root of x minus x. Maybe I'll just write down the distance formula. It's the square root of x2 minus x1 squared plus y2 minus y1 squared. This is the distance formula. So if I use the distance formula involving these 2 points, I'm going to do x minus x. So that's 2 minus -3, so which is actually 2 plus 3 squared. And then I will do y minus y, so 5 minus 17 squared. This will ultimately get me the radius. So this is going to be 5 squared, and this is going to be -12 squared. So that's going to be 25 plus 144. So that's 169. So that is 13. So I did all that and I found that the radius is 13. So now I have the center and the radius. So if I want to write the equation of a circle, it's going to go like this. So it's going to be the opposite of the coordinates of the center. So I have -3 and +17. So I'm going to have +3 and -17. Now here goes the radius squared. So the radius squared is 169. All right, 13 squared. So I put 169. And that's it. Here is the standard form equation of the circle that has a diameter with these endpoints. In number 11, we're told we have a parabola with a focus at -3, 2. Alright, so -3 comma 2, we'll put the focus here, and directrix at x equals 1. X equals a number is a vertical line, so we're talking about a vertical line at 1. So we know that the vertex should be halfway between the focus and the directrix. So these are 4 apart. So if I go 2 away from either one of these, I should be dead center. Okay, actually, so my vertex should be right here. So understand that we're dealing with a parabola that is wrapping around this focus, right in the middle between the focus and the directrix, but going away from the directrix and around the focus. So the main thing we need is the coordinates of this vertex. So the vertex is -1 comma 2. Now, because the parabola is sideways, when it's horizontal, this is the version of a parabola where the y-coordinates are squared. So we're using this model, y minus k squared is equal to 4p times x minus h. This is the version, the model that we use for a horizontal parabola. But we know the vertex. So we're going to put the x value and the y value, the h and the k. But understand that the 2 is going to go in here, and the -1 is going to go in here. So this is going to become y minus 2 squared is equal to 4p times x plus 1. Alright, it's the opposite sign for each of these. So we still need to find what the p value is. We can see that from the picture though, because the p value is always going to be the distance from the vertex to the focus. And if it's going to the left, it's going to be negative. So we can see that this is the focus is 2 units left. So that's why p is equal to -2. So if I substitute a -2 in for p, then I'm going to have a -8. So that gives us the final answer. Y minus 2 squared is equal to -8 times x plus 1. So that's it. Standard form equation of the parabola. For number 12, we have an ellipse with covertices at -2, comma, -6. Okay, so we've got covertices at, hold on, covertices at -2, comma, -6. And 10 comma -6. Okay, those are my covertices. And then we have foci at 4 comma 3. Better just graph that. So these are foci at 4 comma 3. Okay, I feel like I should label these. So this is 4 comma 3. Now remember that these are the yellow points are covertices, and these are foci. So when we talk about A, B, and C, these are these would be found by using B values, and these green points would be found using C values. We do not have any vertices showing here, so just watch out for that. At any rate, the center. The center should be right in the middle of all of these points. So we should be able to pretty easily figure out what the coordinates of the center are. I think I'll write it off to the side though. Okay, the x-coordinate of the center should be the same as these two foci, 4. So the x-coordinate should be 4. The y-coordinate should be at the same level as these covertices, which is 6. The y-coordinate here, I'm sorry, -6. The y-coordinate is -6. So 4, -6 should be the coordinate of the center. Now that is plenty enough to start building the equation of this ellipse. So we always start off with the x term when we're writing the equation of an ellipse. And because the center is 4, -6, I'm going to have x minus 4, see how I'm doing the opposite, squared. And then for an ellipse, this is always plus. And then y plus 6 squared, doing the opposite of that. And for an ellipse, we're always going to have equal to 1. So now we just need to talk about the a squared and the b squared. We don't know anything about the vertices, but we do know that these yellow points are the covertices. So you see how the covertices are horizontal? So look, the covertices give you the b value. So from the center to a covertex, that is a b value. So let's see, from 4 to 10, that tells me that I have a b value of 6. So that means that b squared is going to equal 36. Now, am I going to put the 36 with the x term or the y term? Well, look, this is horizontal. So I'm going to put it with the x term. All right, this is the x direction. So the 36 definitely goes here. Now, we need a squared. We don't have that. What we have is a c value. If I go from the center to a focus, because remember, that's what this is. This is not a vertex. This is a focus. Okay, the real ellipse goes like higher than this. I don't know exactly how high, but the real ellipse extends beyond this. Anyway, so this is the c value that I'm showing you right here. So let's see, from -6 to +3. That's 6 down, 3 up. That's a total of 9. So c is equal to 9, which means that c squared is 81. What we need is a squared. For an ellipse, the relationship is c squared is equal to a squared minus b squared. For a hyperbola, this is plus, but for an ellipse, it's minus. But we know that c squared is 81. We're looking for a squared. We know that b squared is 36, so minus 36. So if we want to find a squared, we have to add 36 to both sides. And this will give us a squared. So a squared is 117. So that's it. This is the standard form equation that we needed. There you go. Alright, for number 13, we're dealing with a hyperbola that has these foci and these covertices. Okay, so I've plotted those points on my little bootleg sketch here. My foci are in green. I have a color system. I always use green for the foci for some reason. So my covertices are here in yellow. Remember, this is the hyperbola. The center should be pretty easy to find. So it should be right in the middle of all four of these. So let's see. The x-coordinate of my center should be at -5, like the covertices. The y-coordinate should be at +1, like the foci. So -5, +1, here's the center right here. Okay, I really could start writing the equation of my hyperbola now. Because of the foci, I know the direction that the hyperbola is facing. I don't know exactly where the vertices are, but the branches of the hyperbola have to wrap themselves around the foci. Okay, sort of like this. So I know that this is a horizontal transverse axis. So whenever a hyperbola is horizontal like this, the x term goes first. So I'm dealing with this model of a hyperbola. It should be x minus h squared, all right, over a squared, minus y minus k squared over b squared is equal to 1. So this is what the standard form equation should look like. I just need to fill in some of these variables. So the h and the k are the center. So I can definitely fill that in right now because I do have the center. So it's going to be the opposite of these two. So I'm going to put +5 here and -1 there. So now all I need is a squared and b squared. Well, the a value is the distance from the center to a vertex. I don't have that. So forget about that for now. B squared. Well, b is the distance from the center to a covertex. So I can find that. So the distance from the center to a covertex, that's b. So that's from 1 to 9. That's a difference of 8. So that tells me that my b value is 8, which means that b squared is 64. So I know my b squared, so now I can go ahead and put 64. Alright, I still need to find a squared. I don't have a squared, but what I do have is the c value. The c value is the distance from the center to a focus. So this is going to be the c value. So this is going from -5 to +5. That's a distance of 10. So that tells me that the c value is 10. So that means c squared is 100. I can use that to help me find a squared. When I'm dealing with hyperbolas, I know that c squared is equal to a squared plus b squared. For ellipses, it's minus, but for hyperbolas, it's plus, which is funny because it's opposite of the way the standard form equation goes. When this is minus, this is plus. When this is plus, this is minus. Anyway, I know that c squared is 100. I'm looking for a squared, and I know that b squared is 64. So all I have to do is subtract 64 from both sides, and I'm done. So this is going to give me a squared is equal to 36. And that's it. This is the standard form equation of the hyperbola. And there you go. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.